Thanks for joining this session. So look forward to this 90 minutes discussions and whatnot. So I'm Emily Law from Jaipur Potion Laboratory. I'm also a data scientist, but today is mostly what I do is managing programs and projects related to data system and technologies, especially data intensive systems. And my passion is in making data usable. So I think Knowledge Graph is a great tool. Thanks.
Great, thanks, Emily. And I don't, correct me if this is wrong, Lewis, if you're online, but I don't see Lewis in the room at the moment. So if not, we'll just hop over Lewis and go to Barbara Thompson from NASA Goddard Space Flight Center.
Hi there. I'm here largely because Ryan got me in so much into knowledge networks, but my principal interest has been really the transformational capabilities represented by knowledge graphs and in knowledge networks. There are kind of in the AI world, there's kind of these two extremes. One is trying to reproduce what humans do. And in the respect of that, I would say that I would love, if anybody's seeking knowledge, we're trying to know who to ask, if you don't know, it's good to know who to ask, who might know. In the other extreme of AI, from thinking and reproducing human behavior, there's also the target of just goal-oriented or thinking rationally or behaving rationally. In other words, corresponding to an objective and doing it independent of the way a human would do it. And so knowledge graphs are really the kind of a beautiful convergence of both. It reproduces the best of human behavior, but it gives us a capacity beyond human behavior and augmentation, meaning that if I know something and Ryan knows something and someone that Ryan knows something, we have this ability now to build on that and find a relationship that we probably wouldn't have been able to do in such a multivariate system. So that's why, so I'm really interested in the transformational capacity. I'm interested in optimizing what one person knows relative, not just to the people they know, but what's relative to everyone in their environment and allowing us to perform even better.
Excellent. Thanks so much, Barbara. We're lucky to have Barbara, Emily, and Lewis as part of this convening crew in putting this session together today. I'll introduce the other members involved in the session in just a moment. I wanted to start today with land acknowledgement, and I chose to do this for the Washington, D.C. area where I'm located. And I'll just read this how I've written it. We acknowledge that Washington, D.C. is the traditional territory of Nacotchtank, Anacostan, and Piscataway people. We acknowledge that this legacy and find inspiration from this land. This land and other native lands in the U.S. can be explored at the link that I've provided there. It's an excellent resource for those of you interested to look further. By acknowledging territory or land, we may recognize Indigenous presence as we convened for this ESIP winter meeting this week. We each have a responsibility to consider what it means to acknowledge the history and legacy of colonialism in our history as a nation and as a community. Throughout this session, during this session, and throughout the ESIP winter meeting as a whole, we note that the privileges we enjoy today because of colonialism, and we strive to perpetuate colonial futurity. If you could close your mic if you're not speaking, that would be very helpful. Okay, thank you.
Thank you, Ryan, for doing that. That was really thoughtful.
Oh, thanks, Barbara.
Excellent.
So to begin today, I want to start with a quote that sticks with me as I think about knowledge networks. Norbert Wiener said in his pivotal work, Cybernetics, that the most fruitful areas for the growth of the sciences were those which had been neglected as a no man's land between the various established fields. And to me, this is why we're here, to discuss knowledge systems, that in the face of increasing complexity in our science, it has never been more important to link across domains meaningfully. Weiner's words ring relevant now, especially during this digital age, because of the sheer volume of data at our fingertips. Information teeters on the crux, dividing distracting noise and pivotal knowledge. How do we navigate this world and this information within it? How do we organize it so that we're not lost in it? I think the thought becomes even more relevant when we look at the domains of science. And so just to illustrate that, I'm showing here the operating fleet from the NASA Science Mission Directorate that shows astrophysics, earth science, and heliophysics, as well as planetary science. And when I think about this, We recognize that, as Norbert Weiner so presciently put, those most interesting, potent areas are those that operate here in between the fields. And when we look in these in-between spaces, the question becomes, how do we link these bodies of knowledge? How do we understand the relationships between them? How do we navigate those relationships? Not only in the principles of these scientific domains themselves, but also between individuals, projects, groups, and data systems. This is what allows us to create what I think of as a new paradigm of discovery, one that I like to provocatively refer to as anti-disciplinary. So how do we become anti-disciplinary? How do we work in these in-between spaces? And I think that's what we're here to discuss today. To set the lens for each of us today, this session's contribution is not a new conversation, but a continuing and converging of many that have been going on already. We're here today to discuss these questions, not in reinventing the conversation, but in carrying those forward that have been going on already. The unique angle of this session is to converge these conversations, as you will see from our panel that will lead off the session in just a moment, that we've selected thought leaders across these different domains to reimagine the conversation in light of new technologies and recent advances in the technology needed to represent and link information, and those generated from powerful use cases. We would like to chart a new path, understand this more collectively, and really learn from this singular group of people that we've put together today. So thank you all for being a part of this session and joining us today, and a specific thanks to the panel members who will lead off the discussion. The objectives of this session are a few. First, to develop a shared understanding of what a knowledge system actually is, and some of the roles that it has and may play in the future for the Earth and space sciences. We'd like to give people concrete knowledge of how this has been done by collecting use cases and home run stories for knowledge systems and knowledge graphs that link information between individuals, projects, groups, and data systems. We will take a moment to reflect on the things that we learned and trying to distill some of the trends from the use cases that we hear about. And I'd use these to identify new ways that we can move forward as a community and be connected as a community. The agenda today, we are in the midst of looking at the inspiration and motivation for this session. We're going to lead this straight into a 25-minute panel session to hear from some of the thought leaders that we recognize as committee members for knowledge graphs and knowledge graph development. Then we'll make sense of what we hear from the panel members in smaller subgroups. So we'll go into breakout groups for a sense-making exercise. And then finally, we'll come back together and reflect on what each of the breakout groups discussed in an exercise called What, So What, and Now What, that will capture what we learned and set the agenda moving forward. And then finally, we'll conclude from that. I just want to take a moment to call out how we expect people to behave during the session. So we will adhere to the ESIP community participation guidelines. And I've listed the high-level behaviors that guideline points out. Obviously, being respectful, being direct and professional, and opening up the floor to all voices, being very inclusive and allowing different perspectives to have their voice heard during this session. So you can follow the link in the document to the community participation guidelines for the ESIP community. So actually interacting during this session, how will we do that? The first is to help us crystallize the knowledge that we're learning during this conversation. There's going to be a lot of discussion. There's going to be a lot of back and forth. And we've created a collective notes document that you can follow here. And we've posted it in the chat a couple of times. And I think maybe someone could repost those while I'm speaking here. But this is a notes document. Feel free to add any and all thoughts that you have throughout the session to that document as we go along. You can also add questions and have conversation during the chat as we're going through these sessions. During the panel session itself, I'd love if you could put your questions in the chat and we will get to as many as possible. And in general, help this 90-minute session be a springboard for us to maintain a cohesive connection across the community and actually act on some of the trends that we find. So these are a few of the communities that I've just written here as ones that would be nice to interact with and help this work benefit. The ESIP Discovery Cluster and the AGU Earth and Space Science Informatics section. I'm sure there are many others, and I would love for you to capture those other efforts and communities in the notes document so that we can make sure we have them in mind as we move forward. So again, here is a QR code for those of you who might be interested in finding all the materials and having trouble with the links. Here's the link that we'll be using for all of those documents. So what I'd like to do is now move into the panel section. And I'm going to take a moment to introduce our 4 panel speakers, chosen for the breadth of knowledge graph development and work that they have, that they represent. And I'll just step through and in just a brief moment introduce each of them. So the first panelist is going to be Juan Cicada. He's principal scientist at data.world. I've included a couple of links for you to follow him online if you don't already. Juan researches the socio-technical phenomena of data integration in order to deliver beautiful data from heterogeneous real-world enterprise databases, such that those data can be easily used by non-technical users, business intelligence tools, and machine learning applications. We're extremely lucky to have Juan Cicada be a part of this session, and thanks, Juan, for joining. The second panelist is Christoph Janowitz. He's a professor of geographic information science and geoinformatics at the Geography Department at the University of California, Santa Barbara. Jano is the principal investigator of a really brilliant project called the Nowhere Graph, or Nowhere Knowledge Graph. It's a project funded under the NSF's inaugural Convergence Accelerator program and was recently chosen to go forward with phase 2. So absolute congratulations to Kristoff on that. Additionally, he is the UCSB program chair for the Cognitive Science Department, associate director of the Center for Spatial Studies, and one of 2 editors-in-chief of the Semantic Web Journal. He's a faculty research affiliate of the Center for Information Technology and Society and a community leader of the 52 Degree North Semantics community. So he brings a wealth of knowledge to this panel. Our third panelist is Lailani Gilpin. She's a research scientist at Sony AI and a recent PhD from MIT CSAIL. Lailani is a leading researcher and thinker in the field of explainable AI, and someone bring those tools of semantic technology to bear on the important problem. She's going to add a really rich perspective of how knowledge graphs can be applied and their underpinning of successful AI/ML, which I think is a really critical perspective to have in this conversation. And our fourth panelist and final panelist is Deborah McGinnis, Tedalus World Senior Constellation Chair and Professor of Computer and Cognitive Science at Rensselaer Polytechnic Institute. She's also the founding director of the Web Science Research Center at RPI. Deborah is a fellow of the American Association for the Advancement of Science for contributions to the semantic web, knowledge representation, and reasoning environments. She blends computer and cognitive science as a central member of Tedalus World and is generally a leading authority on semantic web and has been working in this area for over 30 years. And we're extremely lucky to have each of these panelist members join us today. So what I'm going to do is stop sharing my screen and let's see if we can pop out of that. And we will move over to the panel discussion. And I'd like to kick things off. We will open this up to questions. And so I hope people can include their questions in the chat, but I'd like to kick it off with starting at the foundation to kind of put us all on the same footing here. I'd like to just go around to each of the 4 panelists and ask the question of what is a knowledge system? How would you define it, and how would you set the boundaries of our discussion today? And Deborah, maybe we'll start with you.
Sure. Well, I used to run the knowledge systems lab at Stanford, so this is probably pretty good. In fact, I just went to the knowledge systems page, and it's, you know, it's a little old the way we defined it then, and doing research in knowledge representation and automated reasoning. But really kind of anything that brings together data in a meaningful way and answers maybe some useful questions. But, you know, now that you can ask me what a useful question is. So kind of an integrated system of data with some meaning attached to it.
Kristoff, how about we go over to you?
Boy, going on that topic seems kind of a difficult task. So I agree with the meaningful that this is the key here. And I would maybe say readable to humans and machines, as we so often say, and also reasonable to humans and machines so that we can draw conclusions from that, ultimately telling apart just more data, which I think we don't want, from more insights, which I do think. You're muted.
Thanks, Kristoff. Thank you. And Juan, how about over to you?
So I'll start with a little bit of history. I will think that let's look at knowledge and look at data. Since the big sort of last, I don't know, half a century, whatever, we've been understanding. There's a community trying to understand what is to manage knowledge and manage knowledge at scale, right? And I think that's all the work on knowledge representation, and Deborah has done immense contributions in that area. Goes back since the 70s, 80s, right? Then you also have data management and managing data at scale. That's the entire database community, creating these systems to go manage data at scale. And what we're seeing now is kind of this intersection, and it's been happening over the last 50 years, of being able to combine knowledge and data together. And I think today what we're seeing is that we have these techniques that have been done independently of managing knowledge at scale and data at scale. Then now we're coming to be able to combine knowledge and data together at scale. So I think this is what I would call that's my definition of what is a knowledge graph. I mean, it's a manifestation of kind of that vision of doing knowledge and data at scale. You specifically asked for what is a knowledge system, so I'm going to hijack your term. I'm saying in reality, what we need to be thinking about is how to go manage knowledge and data together at scale. Well, we have been looking at these things independently for the last 50 years and much more too.
Excellent. Thanks, Juan. And Leilani.
I think everyone said really key things, thinking about data being in a meaningful way, that it's understandable and reasonable. I also think that it has an aspect of reasons attached to the facts. So you know where those facts came from, or whether you should believe them as full truths, whether it's common sense. You have some way to sort of, dare I say, backtrack that knowledge and be able to sort of defend it.
Thank you. In my experience, it's very easy to recognize the benefits of a knowledge graph. And so one of the natural questions that arises is, why are these not more prevalent, not more widely used, and especially in the sciences? I'd love the panel's perspective on that. And feel free to go ahead. You don't need to. Yes, Kristoff.
So one observation that always strikes me, especially also in the group that we are here in many projects on what we call data infrastructure that have tried this, is that they're on the level of data sets, right? So they tell you, you can find this here, or if you care about observations of this, go here. What makes knowledge graphs so specific is that they're at the level of individual data statements, like the temperature in Santa Barbara is 70 degrees right now or something, right? So this is what suddenly puts a data set that you can find into a collection of statements that you can actually process both as a human and of course as a machine, let's say for question answering, which I guess is a very important application these days. But what's a very important distinction, how much data do we actually want? About what do we want to be the data? And especially in this community of environmental data, at which resolution? Because I can certainly flood you with more that you will be able to handle, right? So I believe, and I like what was said about this, about the previous question, is that we don't really know yet what questions should be asked to knowledge systems. And that makes selling them outside of our community not such an easy problem as may meet the eye.
I'd add, just quickly, I'd add kind of from the social side. We're just used to the status quo. We don't like to change. I'll keep that short and simple for now.
I wanted to add on to we kind of don't know what questions to ask. And I might add that we're not very good at meaningful evaluation sets or benchmarks. I was just on this Machine Common Sense DARPA program, and the language models are killing the benchmarks, but they clearly don't understand the data that they're working with. But yet they're not only hitting the benchmark numbers, they're just knocking it out of the park. So, what that tells me is not only to build off of Christoph's position of we might not know the best questions to ask, I think we are looking for models to evaluate. We need better models to evaluate, and it might not just be question answering, it might be some kind of interaction model.
I'll add one more quick point. I think that when you think about applying knowledge graphs to something that's application or domain specific, it's really difficult, and it's hard to either take an existing knowledge graph and figure out the specific application specific knowledge you need, and it's even more difficult to create, your own sort of knowledge graph for that application. So it's a lot of sort of hand labor that other people will throw a machine learning system with a lot of data in it and it works immediately, whereas curating this type of knowledge takes a lot of time and effort.
And I want to add another thing is at the end of the day, all this knowledge graphs and all this stuff, it's just a fancier, newer way of doing data integration, right? We're integrating data, but we're also bringing in knowledge, right? The kind of the bringing in the concepts, the relationships become first-class citizens, not just 72, right? But that's a degree. They have the whole kind of model around what that stuff means, right? So that's one thing. And second, I think what we need to revisit is, what does success mean? I mean, first, we always focus on success from a technical perspective. Give me data. That's not really what you need. Your goal is, I need to go answer this particular question. Oh, by the way, I need data to go do that. And oh, by the way, you don't need all the data to go do that. You need a subset of that data. So while we end up focusing on saying, give me the data, and I need to go build up these warehouses or the knowledge graphs or everything, in reality, our goal is to answer questions. And then you need to say is, for whom? So you need to talk to the people, right? And understand what they're trying to go do. Data and integrating data knowledge is a means to an end. Think about, what does success look like?
Thank you, Juan. And I think it really raises an important point of that it is very difficult. And I think it's from those who don't actively work with advanced data integration systems, how a knowledge graph is actually built. What are the things that go into it? I know a lot of people that I work with always wonder what the technologies are. And I think it gets back to Deborah's point on, this is something that's been done for a while. And I'm wondering, I guess, two things. Why is now different? And what is the actual approach? What are the steps to creating the knowledge graph? If you're working on a project and you want to better link the information and even pull in information outside of the immediate boundaries of your project, what are the steps to do that?
So let's start with some things that are different. We can work at a level of scale that we couldn't, decades ago. That's one. Another one is the accessibility of openly available open data is completely different. So the data availability and the scale are different. But the problems are still not that well, some of the problems are still not that well defined.
Could you give me maybe an example of what you mean by ill-defined problems? How can we better scope this for knowledge graph creation, Deborah?
So, I've been doing ontologies and knowledge graphs since before knowledge graphs had that title. And sometimes people build ontologies and knowledge graphs and say, build it and they will come. But I love building this stuff, but I don't want to really build these things until I know why I'm building it and who's going to care. And actually further, until I can describe that in a way that a lot of people can understand when they should and when they shouldn't use my stuff. So like, what's the sweet spot? Where are the weaknesses? How might other people leverage it? And I think until we get that better defined, the problems are not all that well defined.
Yes, Kristoff.
So to some degree, knowledge graphs are about the 80-20 rule, so to speak. So they are about the balance of how much knowledge do you want to get in an available form, because this is what makes knowledge graphs, versus do your own analytics. And we are used to doing our own analytics, but now, and this addresses the what has changed question, the industry, whether this is, government agencies, industry partners, humanitarian relief organizations, they are on the situational awareness train, so to speak. They all understand the need to talk to this community here about environmental awareness. You need to understand if you're producing iron ore about bushfires in Australia like this. But they don't have all of them like, a full division of data scientists sitting there. So they want to reach out somewhere and get insight as a service. So that's, so to speak, the sales point of knowledge graphs. But of course, you could always just go back to the source data, which is very high resolution, and get the insights yourself. So the balance becomes, what can we offer as a knowledge graph that makes insight readily available versus you have to go to the source data and be a data expert as engineer yourself. And I think this relation is really tipping in our favor, so to speak, with massive influx of interest from the industry in intelligence in terms of environmental intelligence and situational awareness and so on.
Thank you, Christoph. Juan and Leilani, I'd love to hear your thoughts.
So to go specifically on how to go build them, I think, so first of all, it's people, processes, tools, technology, right? So let's think about the technologies, right? And so first of all, you want to be able to go think about what are the sources of data. What's the input and what are the outputs, right? Your inputs can be a bunch of can be unstructured data, it could be semi-structured data, it could be structured data, it could be a mix of those things, right? And so are you trying to extract data and knowledge from text, right? From the web, from a semi-structured, let it be web tables on the web, or some stuff from Wikipedia and so forth, right? Structured data, do I have structured relational databases, or right? So what is that type of, so that those are going to be the sources that I'm going to go take into account. The idea of the whole knowledge graph is that you want to be able to have, and this is what I call the beautiful data. What I mean by beautiful data is that I look at the data, I access the data and I understand it. And if I don't understand it, I know who to go talk to and go figure that out. And literally, it's what you go draw on the whiteboard, right? What do we do when we go talk to people? What do we draw on a whiteboard? Guess what? We draw a graph, bubbles and lines. That's how we try to express things. And the thing is that we think about it that way, but then what traditionally been done is that then the data gets spoiled from the conceptual model to a logical model to the physical model. And then when people start to go access the data in the physical model, because that's how I have to go query the data, it's completely separated from what I'm thinking about it, what I drew on the whiteboard. The whole idea is, what if I drew it on the whiteboard and that's a whole way I access it? That's why you want to have a knowledge graph, which bridges what I call that conceptualization gap, that data meaning gap, to go do that. So then there are technologies to be able to go create the mappings, right? Mappings from all these source different systems to go put them into a graph. There's all this NLP technology that can go in and extract do entity extraction and so forth, put it into a graph. There's graph databases to go build those things, right? That's a technology part. So that's one thing. Second, you need people. Right. And traditionally, we all talk about the data scientists spending 80% of their time doing the cleaning and stuff. When in reality, we need to agree that 80% of the time we go complain that it's just clean up data. That's true knowledge work. That's what I call the knowledge science work. That's understanding, wait, there's these three different people who use three different words, but they kind of seem the same thing. Or there's three different people who use the same word that mean different things. Like, who's actually doing that work and who's cataloging that work and who's going off and figuring out where's in that data? That's the people side of it, right? And a lot of us think that a lot of people think we need to have a magic wand and AI is going to go do that. I think that's an AI complete problem, simply because you put humans in the room and they won't even agree. Why the heck do we believe that machines are automatically going to come up with the right answer? And why do we believe that we're going to believe them, right? And then the third is the processes. Is that we need to have methodologies, right? Are we just going to throw stuff at the wall and see if it stinks? Or if it sticks? No. We need to start small, otherwise we're going to go boil the ocean, right? And just kind of as a final thought is, we know how to build software. We need to treat data the same way we treat software, right? No way in hell would you ever tell somebody, go write code without comment and push it to master without test. Never, ever. We do that for data every day. Ask yourselves, why do you do that? And finally, ask yourself, who's responsible for your data? Who gets fired if something horrible happens? Who gets promoted because something amazing happened? Who's responsible for your data? I'll keep it at that.
Thank you, Juan. Leilani.
I guess I'll just make a quick point. I think a lot of wonderful things were said. if you consider, again, what's being done at sort of the mainstream work today in AI and machine learning, they're largely, i.e. these large data-driven systems. And when you try and incorporate those with a knowledge graph, they just don't speak the same language. For example, if you're looking at something like image detection for self-driving cars, something that could really use a lot of information from knowledge graphs, they're trying to detect what they're perceiving with a very high accuracy. And if you're trying to add, either common sense or knowledge graphs to that, it's not exactly clear, because if it's something big and wide, you want to be able to query a knowledge graph or something like that, and it might not even be represented in that way. So there are lots of different sort of levels of abstraction, especially trying to integrate these systems today.
Thank you. I think this is driving to a point that I did want to get to, and it speaks a little bit to Barbara's question that's in the chat here. But Juan, I love your idea of your concept of the knowledge scientist. I think the way that you think about this data cleaning is really knowledge generation. And part of the problem, at least in my perspective, from some of the scientific incentives that we place, is that knowledge is not incentivized to be collected and crystallized. And so a lot of that really valuable information is sometimes lost. I'm curious how you see us incentivizing the knowledge scientist, or that component of a scientific application, in the creation of, how knowledge graphs can play a role in that.
So first of all, I think we need to start realize that there is this role that's needed, and we're not, there is this role, this function, right? And it's actually the team, right? So it's more than just a knowledge scientist. I mean, I'm seeing this job role now in the industry called the data product manager. And if you do the analogy back to software, right? And when you do this team, you have a product manager, right? That's the person who talks to the business folks to get the requirements. They figure out, right? They go communicate with the software engineers. They're going to go do this stuff because the software engineers are not going to go talk to the business users, right? So there's that bridge behind it, right? In a software team, you have people who are actually going to write code. People are going to go do testing, right? You have the infrastructure to go do testing and CI/CD, right? DevOps and all this stuff. We use Jira and Kanban boards, and we have agile methodologies. Like, first of all, we should sit down. I mean, hopefully everybody in the room saying, why am I not doing this? Like, I used this data today to go do something. Like, holy crap, where did that data come from? Like, do I trust that? Like, truly ask yourself, and then ask the implications of not knowing where that stuff comes from, right? So I think we need to have a realization of that. And second is, honestly, the most important people who need to have that realization are the folks above, the executive levels, and they need to realize that this is something important. They just need to mandate it. It's your job. You don't like it? Too bad. Go somewhere else, right? I think it just needs to be mandated to that level. Another aspect is we need to look at history. This is not, I'm not coming up with this term, right? I'm branding it like knowledge scientist, but go back to all the work in the late 80s and 90s. This is knowledge engineering from the expert systems, right? Deborah can speak to a lot of the stuff that we did. I would argue that during that time, the focus was more on the knowledge side, right? Let's go interview people. Let's go build rules to go create expert systems. But now we're at like, wait, I need to go create the knowledge, but I need to go get the data and put that stuff together. So we need to really revamp the work that people were doing 25 years ago and take it up to today. So I think it's really just us having a kind of a kumbaya moment, an aha moment, saying, oh, we really need to treat data with the respect that it deserves. So for example, like we always say data is the new oil, but we don't treat it with the respect. And we say, oh, that's data janitorial work. Really? You're treating your important data, your knowledge as that's just cleaning up not the way.
So I'd like to add something, because I rarely disagree with Juan, but I disagree with your statement that you should just mandate it. I'm listening to a book right now called Intrinsic Motivation at Work. And I think we do have to find ways that people want to do this, not that they're just being told to do it. And some of those motivations are something like an H-index. I don't think an H-index is it, but and something that we had at Bell Labs like a gazillion years ago was Thief of the Month. So who reused an idea and whose idea got reused, they both got kind of brownie points. And I'm thinking that part of the key is really good, understandable metadata about what was done to the data, when you can use it, what it means. Actually, so this part I do agree with the beautiful data, which is data that you can actually understand. I think I'm channeling Leilani for the understandable stuff. Both of us actually did theses in explaining AI systems. So I think part of the answer is metadata or some kind of description of the data that helps give people intrinsic motivation to do it.
Kristoff, Leilani, anything to add? No.
One thing I would add quickly is I think you're spot on. I'm looking at the chat here too. Like metadata is key. And I would argue that your first knowledge graph should be of your metadata first, so you understand what you have.
Yep.
And what I mean by that is I want to go catalog all my data. Let's catalog what data sets do I have? Who are the people that are the stewards for those data sets? Where do those data sets come from? What are the column names of these things, right? I'm not even getting to the data, to the actual, to the numbers, whatever. I'm just like the metadata. Like, how is this data arrive? Like, let's go get the provenance of that stuff, right? That should be the first thing you go do to understand what I have. Right. And after that, you're like, okay, that's going to help me go find it. I'm going to go search for this stuff. Later on, we go recommend things and stuff like that. And then I want to go, okay, now I found it. Let me go access the data. When you start accessing the data, like perfect, then you realize, wait, what does this mean? Like that. And then you realize I want to go put this layer of knowledge semantics on top of it. But I would say that your first knowledge graph should be understanding what metadata I have and how it's connected with other metadata. And people are also metadata too.
Well, I'm going to disagree with you here just for the sake of disagreement. I think, metadata is not exactly new. And the importance of metadata is something that I tell my students in, first class of Geographic Information Systems. But one of the key strengths of semantic web, and I think one of the key parts that make the RDF revolution, if I may say so, is that it gets away with the metadata description. Data, if it's proper RDF and linked with an ontology, is connected already with its metadata. The data and the metadata is born naively together. And I think that's the key part. Every time you believe that you can maintain, the data and then come up with the metadata, then you're running into a problem. And I hope Peter Fox is on this call here, because he said, a few years ago to me, when we had this discussion, he said, here's the secret about metadata. There is nothing like a complete metadata record, because the entire deal is you don't know who's going to use your data 20 years down the road. This, unintended or, opportunistic reuse is, after all, the key of data science, so to speak. So I guess the beauty of what we are doing is we are not making metadata. We are doing data, and data that is self-descriptive.
I have to disagree with you completely, Kristoff. I think if I'm not going to have metadata, that's like I don't even know what's in my closet right now. It's like I have my closet literally here, and I don't even know if there's shirts or shoes or whatever. I'm not saying I'm going to go. The metadata is the end goal, right? It's a means to it. I need to know what I have. That's literally what it is.
Well, now we're talking. You came to fight, right? I think what I wanted to say is metadata and data in RDF are the same, right? If you have a proper knowledge graph, then your data is self-explaining to the users that may have, future requirements. And that's, I think, one key value propositions of RDF, and this is where a lot of the beauty of what we are sitting.
But I think the first thing we want to go do, we got these standardized ontology, DCAT, right? What is DCAT? What is the ontology? What are the things? It's a concept, it's a catalog, or it's a data set. I got a column. That's what I'm cataloging. So that's my knowledge graph here. So we're being very meta right now.
Well, I think part of the issue is trying to figure out where the edge of data to metadata is. It's blurred. And RDF, actually, one of its strengths is that you don't have to make that distinction. But we do have to describe what we've got. And whether we want to call that metadata or not is kind of somewhat irrelevant. But we do really need to describe what we have and link it to vocabularies that people can understand.
That's true.
Well put, Deborah. We've got a few minutes left on the panel here, and I'll make sure we get to a couple of things of this session. So I'd like to ask each panelist, when you sit down, for those people who don't who've never built a knowledge graph, when you sit down to actually build one, what are the tools that you use? Are there technologies that you point people to that are new and help us actually accomplish this?
I'll start giving that. I'm not the, I represent a company, so, but I won't just pitch what I'm doing. So I think, first of all, there are technologies for sure, but remember, don't forget, there's the processes part, right? One of them, you need to go able to be able to go create your model, create your ontologies and stuff like that, right? So there's open source tools, right? Protege is a very popular open source tool for that stuff. I think there's commercial tools. We created one, I think, called Grapho. You can go gra.fo. It's a visual collaborative kind of Google Doc style for creating your schemas of that thing. And then frankly, you need to go put data into your graph, right? Or create those mappings. And then there's just, I mean, there's a bunch of these NLP type of technique tools to go do entity extraction. There's the whole community around automated knowledge-based construction that focuses a lot on automating from unstructured data to things. On the structured side, there's this whole standards to do mappings. There's the R2RML, the relational database to RDF mapping language, and another extension of that is called RML to go do mappings from XML or JSON data, do that. And then you can do things you can go create your graph from a virtual manner, right? Or you can go dump things into a graph database. Yes, we're talking about RDF, but this may be another discussion, but frankly, at the end of the day, it's just a graph. So if you want to go put your things into a property graph, you can do that too. It's fine. And then there's a variety of graph databases. That's at a high level things what to do, but it's not just about the tools, right? Remember about the people and the processes involved too. I use spreadsheets too, right? It's nothing bad with that.
Thanks, Juan. Leilani.
Yeah, just to echo all that, I use a lot of RDF in my work. I think it's sort of the reasonable place to start. Another knowledge graph, common sense database that I use that has pros and cons is ConceptNet, and it's a nice way to sort of visualize that data, and you can also see it in many different languages. But I think just sort of going through and exploring them for yourself is the best way to get acquainted.
Kristoff and Deborah?
So I'm crazily opportunistic. Basically it's what the people are comfortable using. And because I am an academic and I work with a lot of academics, I use more open source tools than anything else, but I do a ton of spreadsheet work, and I have a ton of tools that suck in stuff from spreadsheets and then get them into I usually drowned out in RDF, but worked in more expressive languages. I think the most important thing is being able to represent it in some form that can be reasoned with and can be understood and can be shared and manipulated, and that your people can use. So I don't want to dictate tools on people and have them come up some long training cycle. If they like some other tool, I'll adapt.
Go ahead, Kristoff.
Yeah, let me just open source here, because I do believe it's key. It also goes back to the question, why is this taking off right now, or why would you even care? I believe that we should all be using the tools that we are confident with, and there are many, and there's a role for commercial and open source and whatnot. I'm not questioning this, but the fact that the semantic web technology stack is all based on W3C standardization, which is a consensus-based standardization form, and that every time you do a standard, you have to show reference implementations that ideally are also open source. This is a very, very big argument. And look at also other parts of the argument. We love to talk about diversity these days. So look at diversity as it plays out geographically. The fact that no matter where you are on this planet, no matter how limited your resources are there entrance paths for you, your data into this entire ecosystem of the semantic web by free implementations, open source tools, open content repository. This matters greatly, I believe.
Thank you. Very useful discussion. We are at the end of the panel. I want to ask one final kind of lightning question. we talked about identifying the home run stories, the places where we can learn rich lessons from. So I'd like each panelist to offer what they would see as their best home run story for knowledge graphs. What's one project that really, in any context, in any kind of way, changed it particularly well? Go ahead, Kristoff.
Well, I'm not going to toot own horn here. I certainly have this that I love in my work, but I'm going to toot Heiko Paulhein's horn, who 8 years ago, 9 or 7, who cares, made this explain a lot thing. Maybe some of you recall, if you don't, look it up, which was the idea that, you know, most statisticians would hate because it violates causation and correlation. He came up with this idea. You would like to know something, and you would like to know what causes this. For instance, why do we see such, you know, lower mortality of COVID-19 in the, let me say this, the developing countries, so to speak, and why is the mortality so much higher in, you know, the Western world? And I apologize for these terms. And he said it's actually very easy. You go out to the link Open Data Cloud. I have this tiny tool that I programmed over, you know, the weekend or a few days, and it's going to go to all the individual things about all the places it knows, and then come back with all the data to do very simple, you know, correlation and analysis. I do understand why some people are unconfident with mixing correlation and causation, but I think this is such a strike home story that he did there many years ago, because it sells value proposition. Do you know why the mortality rate is higher in the developing world? Simply because in the developing world, the population is older on average. And now you're thinking, well, I knew this, but keep in mind, there are tons of variables to explore. And this tool, this is based on linked open data within seconds in front of your eyes. And whenever I show this, everybody still gets what we are trying to do here. So I still love that example.
Deborah, how about you?
You know, I'm thinking about a range of kinds of home runs. So one type of home run is longevity and pedagogical usefulness. So this, I will toot my own horn. I did this wine and food comparing system actually in the 80s that people still reference versions of it today. It was tiny. So the knowledge graph itself was tiny, but it helped people understand the technology, and it's been at the basis of, you know, W3C documents and how to build your first ontology and how to use semantic technology. So it's got a pedagogical and longevity component. I think Kristoff's example was kind of an insight, you know, getting an insight faster or without a lot of extra explanation. And I think I could probably give some number of those. Like I've got one project with the National Institute of Environmental Health Science that helps look at exposure and relationships to health, and then helps integrate data, harmonize data, and then integrate it so that analysts can pool data and draw conclusions from larger populations. So, you know, I don't think it was quite met Christoph's example of, I just show a graph and poof, people get it. That might be an overstatement of what you were saying, Kristoff, but that might be a way to evaluate as well. So, you know, what do we mean by home run? I think there's a lot of different perspectives on home runs. And I could probably write, actually probably the whole panel could write some number of classes of home runs and then give examples of them.
Leilani, Juan, quick responses.
I'll very quickly say something that's not my work, but something that I find very inspiring, which is the work of some of the early work of Watson to play Jeopardy. Is that a lot of the knowledge and a lot of the answers they got was from sort of chaining together different facts from knowledge graphs. And I think it was a huge achievement to sort of show the power of that, especially in the more modern era.
I'll put my industry business hat on for a second, and I'll say, honestly, like all our customers are having their own home run stories, right? I mean, I'm very adamant about the whole metadata being your knowledge graph, because my company Data.World, we are about cataloging people's metadata and put it all together. I mean, I find it fascinating. We work with one of the largest consulting companies in the world, and they started with 100 people. We helped catalog their data, and they had 100 people finding it. And less than a year later, they have 10,000 people are able to go find the data that before 10,000 people were going through emails and spreadsheets, and I can do that. I mean, that's just the type of stuff that we're able to go do: find, search, recommend, just finding data sets. I mean, I can go off and talk about every single customer we have and their success stories, but they're all over the place.
Excellent. Thank you, Juan, Leilani, Kristoff, and Deborah. Really exciting and informative discussion. Thank you very much for being a part of this. And what I'd like to do now is move to the next part of this, where we've now heard from some people across an eclectic mix of knowledge graph backgrounds and perspectives. And I'd like to bring everyone from the session in on the discussion. And so what we're going to do in the next part is, let me just share my screen really quickly. We're going to move into a sense-making exercise. So for the next 20 minutes, we're going to go into breakout rooms. And we have assigned each of these breakout rooms one of the conveners or one of the panel members to help guide the discussion. But really, this is a discussion for everyone to be involved in. So I posted in the chat this link here. When I open the rooms in just a moment, you will see a room number that you've been assigned to. And for anyone in those rooms, please go to this link, find the breakout room number for the notes document that you'll be contributing to, and there'll be a guide for how to moderate the discussion and what we're actually trying to do with this. So after 20 minutes, we'll come back and we will have a group-wide sense-making reflection on that activity. So I'm going to open the rooms now, and let's see, everyone should see that.
And the documents in the Google Drive, this is Barbara, you can't see the numbers unless you mouse over them, and then it'll show the complete name. So if you're trying to find the document corresponding to your room, it's at the end of the title of the document.
Oh, thanks for that, Barbara. Let me know if you have any trouble with that. Otherwise, we can go to the breakout rooms. Welcome back, everyone. As everyone's starting to join, I think we're still a little low. People are probably finishing up their conversations. We'll give it a few more minutes for people to come back.
Oops.
All right. I think we are getting people back from the breakout rooms.
Dang, that was quick. Ah.
It was quick. It was quick.
It was a
Gotta
good session.
keep it moving on the 90-minute session here.
Yeah, it went by too fast.
That's usually a good thing. So I hope that people had fruitful discussions and they're coming away with a lot of ideas and things they'd like to explore further. Again, this is nice to be at the very front end of the ESIP week. So the rest of the week we can use to carry these conversations forward and to other sessions and the coffee breaks. So I think it's a good seed for us to have these fruitful discussions throughout the week. What I think is really important for us to do in terms of the objectives of the session, which are to understand what the fruitful areas are for us to move forward, is to have kind of a readout of what we've learned today and what we've heard today. So everyone's heard from those individuals who have spent a good deal of time and work into the knowledge graph space. And we went into smaller breakout rooms to make sense of that experience and knowledge. And now I think it's important to, as a group, collectively bring discourse about the state of knowledge systems for the Earth and space sciences. So I think now is the opportunity for everyone in this group to steer the discussion in the directions that our community will take beyond this gathering. This final exercise to do that is called What, So What, and Now What? And I've posted in the chat the link to the collective notes document for this. And there are a few prompts there that will follow in the final 15 minutes of our session here. And I'm going to try and share that screen so that people can see what we're working on. All right, is everyone seeing my screen here?
Yes.
So this is accessible. I see a lot of people already have this document open. But the first round of this final exercise is called what? And so it's just kind of recapping what we heard and what we got a sense of. So I wanted to maybe place this first prompt. What is a knowledge system and why are they important? And I welcome anyone who was part of these discussions to feel free to open their mics. So this is an open conversation. So feel free to chime in with any and all definitions of what you took away from that.
Can I paste something from one of our breakouts?
Excellent. Yeah, thanks, Barbara.
It's yeah, so we had I like Jackie Saunders, like Marion McKenzie expressed this for when Jackie was talking. So it's team effort. It's exploring the relationships between data, not just looking at data points as separate entities. There. Wait. I just put it in.
Oh, great. Thank you. I think that's a nice capture. Other thoughts, other definitions that people have in their mind right now? Maybe it's not fully formed. That's welcome. That's welcome too. Mark, how about you? I know that you have some thoughts on knowledge networks and how they're created.
Talking to this, Mark?
That's right.
Yeah, my problem is yeah, okay, I'll put something in there. But my group didn't really agree on this. In fact, it's really interesting because there was actually a lot of skepticism about the value of knowledge systems or knowledge graphs in particular, and the amount of time it takes and the value that you get in return. So we had some interesting discussion about that.
Excellent. Thanks, Mark. So let's move to this second question in the what exercise. And I'd really like to know, what are the home run stories? I think it's nice to give these things concreteness so that we can actually learn from them. So did anyone talk about any home run stories that stick out to them?
Well, there's the standard litany, right? Absolutely. So for those of you who are not seeing, Mark's typing in Google, Facebook, Watson, Siri, DBpedia. What about some of the ones we aren't aware of, maybe that we might not already explore? Is anyone working on a knowledge graph now? I think a number of us are.
Would anyone like to offer an example for people to explore some resources that they may be able to find? And you don't have to type it in, and people can capture that, but just in terms of conversation.
So, like working with ontology federations, we wouldn't naturally call it a knowledge graph, but as soon as you plug in instance data to it, it starts to operate like a knowledge graph. You can find instance data, move it around, etc. So there are a number of those, of course, the usual suspects like the OBO foundries of the like OBO Foundry, etc. And with the semantic tech committee here, Lewis is involved also. We're trying to create a kind of systematic approach for the semantic resources that are affiliated with ESIP. So stuff like that, I think, can broaden our thinking there too.
Great, thanks so much. Other thoughts before we move on to the final question in the what exercise? And if you would rather just type into the document, feel free to add your home run stories there. That's going to be available to everyone afterwards, so you can make sure it's recognized there. The final question that I want to learn from people is what they see as the gaps right now. What's preventing us from creating and using knowledge graphs? What did you learn today? Everyone understands.
That pool.
My name's Adam Shepard. I came from software development, and I think we've been working with knowledge graphs for a good while, but I think it's just really hard to get your typical software devs spun up on all the knowledge that they need to effectively work with these. So I'd be curious what others think in that space.
Excellent. I'll offer one. I think knowledge graph adoption, whether it's by funding agencies in incentivizing whether knowledge graphs are part of a project, whether it's worthwhile for that project, and just in communities. There's a not insignificant amount of effort required to learn these technologies, to use them to enrich your data that you're working with beyond the research that you're directly doing. And so I think gaining adoption and allowing people to understand the importance of knowledge graphs is one of the key gaps that I see that needs to be overcome.
I think I'll just chiming in there. So picking up on Adam's point and what you just interjected there, like the training in the technology and tools is one thing, but there's another training about actually handling knowledge, breaking knowledge down into chunks you can then digitize and plug into these things. That's not trivial, and that's often not in the usual training stack of your software dev or your data scientist.
Well said.
I have a comment. I think it's probably easier to start up a new activity where you build in the new technologies compared to an already existing system that's managing a lot of data, and bringing in the knowledge graph technology into that, is knowledge systems into it, is probably more difficult, considerably more difficult.
Thank you.
And for it to be fully useful, you need to build it into the operating system, something that's been operational for years. That makes it difficult. And that's probably one of the reasons why it wouldn't get adopted as quickly as you would like.
Thank you. So I'd like to move to the so what, which we're kind of hinting towards anyways, is now that we've learned these things, that we have these different, different language to describe knowledge graphs and think about knowledge graphs. What does that mean? How do we, what does it imply for us to move forward with? And I've offered some prompts here that you can go ahead and respond to, but I'd love to hear more generally what people think to that. What will you be doing as a result of this session? What kind of new things might you be thinking about? Anybody have any thoughts?
Brian, could you repeat that one more time?
Yeah, we're in the so what portion now. So now that we have this new thinking, new awareness of knowledge graphs, what does it mean for, what does that actually mean for us, for our work?
Well, I think we need to articulate the use cases and the value propositions more clearly. I think that may help towards some of that skepticism.
That's a great point, Chris.
I know in some
One
of
thing
it,
that, go ahead.
and I know
No,
in my group we were saying, you can see the opportunity and you can get really excited about it. How do you get started? And kind of that, how do you take that first step?
Yeah, getting started was something we talked about in our group as well. I actually think Deborah McGinnis put it well, that it's kind of a gift and a curse that we have an enormous amount of tools, but there's not one single route, not one single entry point to it.
When our group, our ESIP lab group, was kind of researching knowledge graphs and knowledge management, we actually had, or at least I personally had, a hard time finding those kind of gold standards and use cases beyond the NASA example. So if that was maybe a little more marketed, might help with buy-in.
For me, the contrast here is the difference between the ER model, the conventional relational databases, and how well they play with the web in a very, flexible manner. And I think Simon in the chat mentioned open world. And this is for me where the graph model is just super exciting. And the question about, how do we make it clear what graphs are good for? It's almost like saying, well, what is the relational model good for? Why is that good for storing databases and creating databases and, going through normalization processes and, stuff like that to get, CRUD and ACID and those. I mean, for me, this is the big appeal is going from the relational model to the graph model, especially given the way it can play well with global identifiers, getting dereferenced through, through the web, interrogating ontologies, and then that whole logical reasoning layer that you get in addition because of the RDFS and OWL axioms that you can build into your framework as well. So the use cases, are always good, but for me, they're like, there's an infinite number of exciting use cases. And I mean, groups like Kristoff's lab and Deborah's lab and, the folks at RPI, they're building solutions based on graphs like this all the time. And now I think we're trying to figure out how to do it at a larger scale with something like the ESIP, if not global Earth Science community. Wouldn't want to do that with an Oracle database. I just don't see how it could happen. You got all these heterogeneous data models already existing out there, and graphs can also help align those.
Excellent. Thanks so much, Mark. And I'll offer what I think is an excellent resource for people. Mark works with a group at the University of California, Santa Barbara, and they do workshops that are sometimes focused on knowledge graphs. The one I was a part of that was focused on training in knowledge graphs. It's an excellent resource. So Mark, if you want to post a link to that group, I think it could be a benefit to everyone here.
Sure. I think actually Christoph Janowitz has been sponsoring those along with Pascal Hitzler. So
that's right. Thanks.
Yeah.
So we won't get to go into full depth on the final round of now what, but that's really kind of the purpose of this session. It's to lay that groundwork and allow everyone to meet new people, get exposed to these new ideas around knowledge graphs and start thinking about them for their own research. But I'd like to offer this final prompt, both for the final 3 minutes and then after we move beyond this to the rest of the meeting. Given everything that we've talked about and that we've heard, what are the ideas, advice, or first steps that you'd recommend? You're welcome to respond openly in the chat or in the actual just live discussion, or post your thoughts here. This is going to be a nice resource for everyone. So anyone have any thoughts they'd like to say out loud on next steps, things that you would like to do, that you think we should do? And I can certainly get us started. It's about one thing about that I'd like to do, and Deborah and I talked about this, that ESIP is such a really unique, singular community. And I think there's a lot of opportunity here in bringing scientists together with ontological engineers, those who are more familiar with these technologies. And I'd like to see us form small groups, maybe around use cases or just discussion groups on carrying the knowledge graph discussion forward. That would be something I think could be a valuable outcome from this.
Yeah, Ryan, this is Brandon. I just want to add, I think that's fantastic. If there were a way to sort of coordinate the efforts, I think that would be amazing. Because I think having many small groups working on their own sort of area of expertise is fantastic. And then having that I don't know if it's overarching, but a place to sort of pool the resources, I think would be ideal.
Yeah, it does need some management. That's a good point. So in our final minute here, does anyone want to add to that?
This is Emily. I think that's an excellent idea to, form either a cluster or some kind of, collaborative group to continue this work. So not only, to share the resources and also share the knowledge and expertise, but also help other people who want to learn about this, right? So provide perhaps training workshops and just to promote this concept that hopefully useful for those, who sees it.
Thank you. So we're at the middle of the hour here. This has been a really productive 90 minutes, and I know I can speak for myself when I say that I've learned a ton. And I want to extend a specific thank you to our panelists, Leilani, Deborah, Kristoff, and Juan. It was a pleasure to learn from you and to hear the discussion. So thank you for making time for this. I also want to thank Barbara, Emily, and Louis for helping me convene this session, and ESIP for giving us the platform for this. And then finally, to each of you attendees, I think this has been a fantastic discussion. So thanks so much, and we'll catch you at the ESIP happy hour happening in just 30 minutes.
Thanks, Ryan.
Thanks, Ryan.
Bye.
Thank you.
Bye, everybody.
Yep, everybody come to happy hour.
Thanks for convening. This was fun.
Thanks, Deborah. Thanks for invite. Thanks, Juan.
Thanks.
Appreciate it.
Fantastic.
Thanks, Leilani.